Today we'll discuss about the cannizzaro reaction. So what is the criteria for cannizzaro reaction? Aldehydes which doesn't contain alpha hydrogen can undergo cannizzaro reaction, and in the presence of concentrated base like KOH and NaOH, etc. One thing we can understand, in aldol condensation we are using dilute sodium hydroxide, that means dilute base, but in cannizzaro reaction we are using concentrated base. So from this we can think, in the case of aldol condensation, alpha hydrogen abstraction is the rate determining steps. So alpha hydrogen abstraction is a very easy phenomenon, because in this case enolate ion is formed, which is very stabilized by the resonance. So less effort is required for this enolate ion formations, so by the alpha hydrogen abstraction, so which can be easily accompanied by the dilute base. But in case of cannizzaro reaction, hydride shift is the rate determining steps. So this is not as easy like the alpha hydrogen abstraction forming the enolate ion. So in cannizzaro reaction we use strong base. Okay, so let's start with an example. We will take, for instance, formaldehyde. Step 1. In the step 1 we are taking concentrated sodium hydroxide, for instance. So what will happen? This is the carbonyl group. Now this OH minus will attack here. Now it will form HCO minus Na plus HOH. Here you see, if this lone pair moves here, OH group might be leaving, but we know hydroxide group is not a good leaving group, and if this lone pair moves here and hydride minus go as a leaving group, this is also not so easy. But the point is that we are using strong base. So in the next step, again it will abstract one more hydrogen and forming dianion. Okay, dianion. Now suppose this lone pair will move here, this lone pair will move here, and this hydride shift will occur. Now this intermediate is in a very good position to do the hydride shifts. Okay, so now we'll go to the step 2. This dianion will now undergo reaction with other formaldehyde molecule. We can see now the hydride shift takes place like this. So what will happen? And here HCO minus Na plus H. Now this is H. So now in the medium we are using water, because the base is diluted in water. So now this structure will be protonated and it will form methanol, but this will not be neutralized. It will exist as a sodium salt of carboxylic acid. Okay, because H formic acid, when reacts with sodium hydroxide, it will form sodium formant and water. Here this is a weak acid and this is a strong acid. Strong acid can form weak acid, but weak acid cannot form. That means I want to say, when this reacts with the water, it should be ACOH and NaOH. Here weak acid and this is strong acid. This is not happening. Okay, so we are getting product sodium salt of carboxylic acid and methanol. So in this case, one is oxidized, one is reduced. Same molecule, one is oxidized. In cannizzaro reaction, here formaldehyde is reduced and other formaldehyde is oxidized. So this redox reaction is called disproportionation reaction. Disproportionation reaction. Okay, now we will focus our discussion about the rate of the reaction. In this case, this is a reversible step reaction. So now write the rate equation. Rate equal to, here the rate determining step is, or RDS, is the hydride shift. In step 2, hydride shift is taking place. So this is the rate determining steps. So we can write rate equal to K formaldehyde and this dianion O minus Na plus. But in the rate reaction, intermediate is not taken. Intermediate is not written. So what we can use this term from this equilibrium constant term. So here if we write K equilibrium equal to this is the dianion HCO minus Na plus HO minus Na plus, and for this formation of this dianion from this formaldehyde, we are taking 2 molecules of sodium hydroxide. So I can write formaldehyde and hydroxide 2. Okay, now I will use this equation here. So it will be K into K equilibrium, ACHO is here. In place of this dianion, I will write K equilibrium already I have written, so only formaldehyde and OH minus 2. So this effective K, now this is SCHO 2 and OH minus 2. So order of this reaction is 4. So in cannizzaro reaction, order is 4 but molecularity is 2. So sometimes some propose that this reaction stops here. So suppose in this case, then step 1 will be HCOH, sodium hydroxide and HCO minus Na plus HOH. Now in these steps This is the intermediate form. Now in step 2, what will happen? Now this anion O minus Na plus HOH, it will react with another molecule of formaldehyde. Now here the hydride shift takes place. Now the product form is HCOOH and HCO minus Na plus HOH. Okay, here this is a acid base, so the base will abstract this proton and form the sodium salt of carboxylic acid. Okay, sodium salt of carboxylic acid. So in this case, when we will discuss about the rate, what will happen? Here the rate, this is the RDS, rate determining steps, rate equal to K and SCHO, and this anion HCO minus Na plus and HOH. But this intermediate is not tracking in that reaction, so in place of this I can write K ACHO, and from the equilibrium term K equilibrium ACHO OH minus. I want to say that it is only one anion, this is dianion. For this formation of dianion, 2 molecules of sodium hydroxide were required, but here only one. So I can write K effective ACHO 2 and OH minus 1. So what is the gist? Here order is 2 plus 1 equal to 3, but molecularity is 2. So when it specifically mentioned, if the cannizzaro reaction takes place in presence of concentrated base, so spontaneously will go for this step, but sometimes it is written like that 15% sodium hydroxide, so you may, in this case we can refer to these steps. Okay, so but this is not so effective because this reaction is very spontaneous, because due to the formations of these dianions, now the hydrogen shift is very smooth, it can easily take place, but it's not so that much easy. So we can say that the yield of this reaction is more here than these reactions. So this is some glimpse about the cannizzaro reaction. In the next step again we will discuss some of the interesting example. That's all.